Hi, my name is Ian McClarty. I'm president of phoenixNAP. And with me today is David Fox, Director of Business Development for American Tower. Today's presentation, we're going to cover a couple key points, but really going to focus on a practical guide to edge computing for business innovation is really the core focus. Today's agenda, we're going to cover 5 different grounds. The first is what the analysts are saying and predicting the future for edge computing. Then we're going to understand the edge technology. We're going to do a quick high-level technical overview. We're going to look at some real-world use cases of edge computing. And then we'll look at the benefits of distributed infrastructure and some edge deploying guidelines as well, best practices within that. So first, who is phoenixNAP? We are a global infrastructure as a service provider. Today, we have over 550 employees worldwide. We have headquarters out of the United States and also in Amsterdam, Netherlands. We're a BV. We also have offices in Malta and Serbia, so we're pretty well distributed. We have points of presence in Singapore as well, so we have some Asia-Pac presence, and as well as Australia. We have over 17 global data center locations distributed throughout the world, and really those are strategically located so that we can have network pops and a good global network reach. We have in our portfolio over 15 infrastructure products that vary from co-location on the very physical space and power side, all the way up to bare metal cloud that is very much API developer focused services, and then in between we have very traditional enterprise services for infrastructure scale out. We've been around for over 10 years. We were established back in 2009, and we continue to grow in the market and help companies really to do performance and scale out workloads. From the slide, you can see our points of presence today. We have several. We have over 17 locations worldwide. We're offering bare metal cloud services in over 8 locations today, and continue to grow that. We're pretty well distributed between the US, some Asia-Pac, and also EU. We have strong presence there. And we combine our entire network pops into one big global tier 2 network. So what is the current state of edge computing? Today, there's a lot of R&D workloads being performed inside edge computing. Analysts are predicting that there's going to be a big uptick by 2026 of more edge infrastructure being deployed. And edge is defined differently by many organizations. The way we classify edge is really more at the cell tower, the locations where 5G is going to be a big part of that. Organizations currently are planning significant edge deployments. So there's a lot of planning going on. About 34% of organizations are doing that today, especially on the big enterprise. There's a lot of R&D workload going on. And then the power requirements are kind of small to begin with. I mean, typical data center co-location services are tending to be much higher. They're trying to go into the 44 kW and above. We're seeing edge deployments be very small to start out with, so because they're very distributed. So somewhere in the neighborhood between 2 and 20 kW. That's a big spread, but within that spread, it's really meant for R&D today. So as it moves more to production, we expect edge to become more power hungry. From this current slide, we can see the shift to cloud and edge. 45% of on-prem solutions are going to basically be distributed back out into more edge locations. The workload is going to be taken a little bit away from on-prem. Public cloud will increase some more. Co-location services will decrease a little bit, but edge will take over as much as public cloud in the near future. This shift will happen within the next 5 years, and we do expect this from several analysts to be the case as 5G becomes more proliferant and becomes more of a regular transport and deployment stack. 5G is still in very early stages of deployment, even though we have it in our cell phones. It is not the true 5G that's going to be in the future. We do expect a higher 5G adoption, and that's going to increase newer workloads that are more reliant on 5G transport. And this is the reason why cell tower deployments are very important to start investing in and to start working on. So the edge computing use cases today, there are several. We have autonomous vehicles that are always the first ones that people think of when we think of 5G and also cell tower deployments and edge. There is a demand for autonomous vehicles, not just on the personal side, but also on the commercial side. We do believe that there's going to be an increase and more reliance on transport vehicles that are moving from state to state, especially with the lack of drivers today. That's going to be a bigger driver on the commercial side. So autonomous vehicles doesn't just cover the personal use vehicles, but also commercial state vehicles. Predictive maintenance is big, especially when it comes to commercial IoT devices. So think of big manufacturing. As manufacturing is moving back more into the US and surrounding countries, that's going to be a big increase. That is one of the biggest use cases that we thought of when we built Bare Metal Cloud to be portable, was around manufacturing, being able to put predictive analytics and maintenance out into the commercial IoT devices, because they do require a lot of data. And then this could save companies millions of dollars when it comes to maintenance. With that, there's also supply chain management. So very similar and related to manufacturing. When we think of like warehouses, all of the supply that's being created back in the U.S. has to be stored somewhere. A lot of supply chain management kind of correlates to the factories, the manufacturing facilities, and back to the warehouses. And then you go back to commercial vehicle, which is again dealing with autonomous vehicles. All this distribution is handled together and glued together. So a lot of information sharing has to happen in real time. And this also cuts down on deployment timelines. So as this becomes more of a driver and more manufacturing starts becoming rebounding back into the States, we're seeing that with semiconductor today. A lot of big investments being performed today on the semiconductor side. We believe that's going to be the case, and there's going to be more of this going on from an industry perspective. Enterprise Edge. The reason why we bring this up, we are seeing the R&D workloads coming from the enterprise. And again, it's to address a lot of supporting mechanisms for some of these workloads that are coming up. You think of big enterprises today, for example, on the software development side, there's a lot of supporting infrastructure that happens with the first three use cases that were mentioned, and they all correlate with each other. And then security services. There's with buildings being more autonomous, less people, and also more 24/7. There has to be smarter deployments being performed on not just keeping buildings safe, but also people safe along the way. And this all there's a term for security when it relates to artificial intelligence on the edge side. It's the visual edge is what it's called. There's going to be an increase in services there as well. And then you have your more standard use cases with healthcare. Again, manufacturing is big. VR, AR, they all relate with each other. But one of the other use cases that doesn't get talked about a lot, but is very real, is more on the rural side, where we see in rural America a lot of farms trying to convert and to become more autonomous. That's also the case. There's more and more driver for autonomous vehicles within that space. So think of tractors, where you have less and less people available, and also people requirement, but there's an increase in food production. So a lot of vehicles today are actually able to be retrofitted within the agricultural space. John Deere has a program to actually retrofit your current tractors to be fully autonomous and to be 24/7 and be able to work the land without the use of human intervention. And so as these analytics and all these, again, going back to the predictive maintenance, the autonomous vehicle, think of supply chain, but think of it more from a food production perspective in rural America. This is also going to be a big driver for edge compute and edge services. And so the future is very much tied to edge. Now in rural America, internet fiber is very constrained and very difficult to build out. So as 5G becomes a more robust and mature platform, that's going to be one of the first delivery vehicles. So what American Tower and phoenixNAP are doing together when it comes to 5G connectivity and also being able to offer infrastructure services together, it's going to be a much bigger driver for companies that are looking for these services. So what are some of the benefits of edge computing? So we'll talk about speed and latency, and really it's to be able to do very quick and real-time decision making at the location. If you have a tractor that needs to make a move in the rural America, it can't go back to data center, think about all these different services it has to do, and then go back and perform that task. A lot of these things need to be done in real time, and so as close to the vehicle as possible. Life safety issues also occur when you're talking about vehicles. They need to be very astute. They need to be kind of almost confined in their own like decision making, but they also need to be aware of their surroundings and be aware that of other vehicles and what is going on there. So information sharing and gathering is very important between different vehicle types. And so latency and speed become not just a necessity, but also a life safety issue. Scalability is big as well. So having data distributed, having information distributed, having it more localized, not having to go back to a data center, saving the information locally, summarizing the information up to a data center becomes more of a scalability possibility at that point. And then you talk about security. So the closer you can keep the data, you secure your data to the edge, not have it to go somewhere else. You're increasing your data privacy, your protection around that, and then you're ensuring that you're able to have a more robust environment that way. So these are some of the high-level edge use cases and benefits, but we're going to see more as the market matures. We are in very early state right now when it comes to what an edge can actually do. Today, we're just talking about R&D workloads, but we are seeing that move into a lot of work and being performed. And as the market becomes more astute of this, we're going to see new use cases that we haven't thought about. So we're really at the infancy stages of edge computing, but we are very excited to work with American Tower. We're very excited at the possibilities that the future holds, and we want to be part of that as a market matures. So I talked a little bit about what we have done and we talked about American Tower. But so today we have launched our first edge location in Austin, Texas. It is a true cell tower location. It is right next to 5G workloads, and we are working on accelerating that faster. There are some caveats there. 5G again, it's not as mature technology yet. You can run services like BGP, for example, around it. But we are working hand in hand with the carriers to make that happen, and we're going to be an early adopter of that technology. We also have low latency to our bare metal cloud systems. Anywhere in the Southwest, it's only like less than 10 milliseconds, and we're really enabling technology innovation with companies. So as we have infrastructure services, people are able to build and have a home for them and have low latency workloads. We're able to have a really good, strong platform for companies to develop strong software around. And there's a really good alignment. And again, as we expand, we're going to build out more cell tower locations. Some will be more rural than others. And this is purposely done because data centers are, again, very hard to scale out. Data is very hard to scale out, and fiber is very hard to scale out. So as these needs increase, especially in rural America, we want to be at the forefront of that. And so how do we make this happen? Well, today we have bare metal cloud, and our bare metal cloud was developed with portability in mind. It is globally available. It is running the latest generation of Intel Xeon-based processor lines. We have access to also transport services such as Megaport. It is very Kubernetes friendly and DevOps friendly. We have a lot of development that's being performed today on what's called on the CI/CD pipeline, more of the CD side of the house. So we have integrated with a lot of third-party modules, making it very easy to absorb services. We give quite a bit of bandwidth away with the service as well, because bandwidth connectivity is very important, and is running the latest and greatest technology stacks, such as NVMe flash storage, and we do have access to S3 compatible object storage as well, and it's very robust and API focused as well. Everything is developed first with the API. The API, as a matter of fact, has more features than even the UI, because we develop with API first in mind, and that's important to us because it's a really good developer alignment and good for people to build applications around. And with that, I would like to introduce you to David Fox with American Tower.
Thanks everyone for making the trip out today. Appreciate it. Again, I'll follow up on some of the things that Ian said and kind of explain who American Tower is. We're not actually a household name in the data center business. We've made a little bit of splash last year and at the end of this year, but American Tower is really the largest cell phone tower company in the world. We own over 40,000 cell sites in the US. We call them telecommunication sites because they're used for other things than just cellular phone installations. We own over 40,000 here in the US, and we operate in 25 different countries around the world, totaling over 220,000 telecommunication sites. We own and operate this network at scale today. We really feel that owning this type of real estate gives us a differentiator in doing edge deployments for customers because the land is secured and we can spin up these edge centers, edge data centers very quickly. So we are, at the end of last year, we also did a purchase of CoreSite, if you're not familiar with that. So along with being the largest cell phone tower company in the US, we're also the 4th largest data center company. We have 25 different locations under the CoreSite brand that operate separately, and we operate as the edge. So we have an existing network to help manage this type of real estate for all different types of use cases. We have a NOC, we have a nationwide team of engineers and technicians that can help take down a customer at scale, right? We could do 25, 30, 100, 200 types of deployments with one swipe of a pen because the real estate is already owned. When you look at other types of real estate owners, whether it be some of the large commercial real estate operators, they don't have signing authority to do types of investments, and a lot of their real estate is wrapped up in JVs. Well, it takes months and months to get permissions to get something done. So we can do something instantly. But what I kind of want to talk about is, because Ian is so good at talking about the technology, we're a real estate company, right? And that's where we are at a core. So I wanted to talk about how we are defining the edge. And what that means to the marketplace and what you can get from a combination and a partnership between a company like American Tower and phoenixNAP, right? So when you look at this defining the edge, what we call edge and the way we are defining edge is edge data centers or the far edge. It's just a term that some people think a large data center with an on-ramp is the edge. What we call the edge is this location out at a cell tower that is going to be hub and spoked into, let's say, an aggregation center, and then can actually go back to a hyperscale or a large core data center. So you're going to be able to have workloads. Someone's going to have workloads. Companies are going to have workloads like Ian talked about that are low latency, that are going to need to be processed at the edge, but the whole thing doesn't need to be done there because the space is going to be limited. So then some of that workload is going to go up to the aggregation center, and then maybe somebody is just accessing some historical records and it goes back up to the large data centers like here in Phoenix or one of our facilities around the country. So what you're going to be able to get through that partnership is a way to go to a one-stop shop to be able to get that whole workload and how it goes through and where it needs to be done at from one company and one partnership. So what is an edge site to us? Traditionally, these are the things that are on our real estate. And when you drive by a cell tower, you might just see this fenced in area and you think that, okay, that's the land that's owned. That's not always the case. There's places where we own acres and acres, but we're not going to spend all that money fencing it off. So traditionally, American Tower, again, we own the tower itself. We own the land and we bring in primary power, which is obviously important for an edge facility. We bring in connectivity, which is somewhat of a challenge. Some of the fiber that comes in, we might only have one carrier. We have at least one carrier on about 98% of our towers that's on net. We also operate a backup generator program already for the MNOs, which makes it interesting, right? Because that's what a data center needs, backup power. And so what we're doing basically is just adding a shelter there that traditionally looks like an edge data center, or it looks like a data center. You walk in, it's got two-factor authentication. It has hot aisle, cold aisle. Our facilities today are 11 racks, 96 kilowatts, about 5 kilowatts per rack, can go a little bit higher than that. But that's just our base case now, and we're adjusting the product as we get requirements from the marketplace and from people like Ian and phoenixNAP that are testing. But the future of edge is really bright and interesting. And people always ask, okay, well, what's coming? And the real answer is, we don't know, right? It's the same thing, because I'm a telecom guy, right? I'm not a data center guy. So I go to Ian for all the data center stuff. I've been in telecom since 1998. And I've watched networks go from 2G to 3G to 4G. And this 4G to 5G lift is a significant lift. It's a massive back-end re-engineering, right? And the 4G networks are going to be operated for another 10 years. They're going to be 5G assisted before it truly gets out and it's a true 5G network. But combining 5G and edge computing and the stuff that our partners can do is really what is going to be critical to obtaining those use cases that Ian talked about. Go ahead. Yeah. Oh, yeah, absolutely.
So you say you actually own all the cell towers, but do you share any network services with like Verizon or any AT&T or anything?
So we are not a network operator.
Okay,
we do not operate a network. We do some things where we'll rebroadcast. We have, and that's the panacea. That's the ultimate goal of we get to, of where we can connect into some of these MNOs networks at the edge. Because what has to happen is the re-engineering of that entire back-end network for that to happen.
So you're mostly focusing on edge computing and data center as such, correct?
As of today,
yes,
we're looking at regional diversity, hybrid cloud solutions, bare metal edge, but then yes, the ultimate goal is to get started early, it's in its infancies, and be ready and prepared of how we interface with the mobile networks to get those low latency applications from the handset.
And then the protocols, and you use CDMA, GSM, both of them, or are you guys on your own, basically?
We don't use that. That's a cellular term, right? So most networks are LTE right now, and it's going to be 5G NR. Or 5G assist, right? So the first 5G network that you're testing to has to have a 4G network to assist you onto the 5G network. The only person that's going to have a true 5G new radio, that's what it's called, it won't be called LTE anymore, is going to be like a dish, because they're architecting from the ground up.
Question regarding the back, you are a real estate company, or you have a real estate license per se, is that correct?
We are a real estate investment trust. That is our categorization. So our revenue that we are looking for comes from the operation of the real estate assets. That's why it's a great fit for our partner with someone like phoenixNAP to do edge computing, because we are not in those services.
The reason I'm writing that question is the process that you have to go through, and it's very unique because maybe the city of New York, maybe doing the San Francisco, or doing outlying areas, or whatever that's there, is you have to know what's in the area per se, because of the process of our terms of deal with something there, you might have to do objections, community, whatever on it. How long of a process is it going to take? Is it fairly long, fairly short? Really, how that's like?
Well, see, that's really, you bring up one of the most interesting points, is that when I get further on, I'll show you some pictures of what the edge data center looks like. And it purposefully looks like a cell phone tower structure. So when I go in and put that in there, there is no questions or concerns about what's going in there, because it looks just like what normally goes in there at the time. And we have zoning and permitting people that have done that for years. So, and that can bring up a security benefit, that you might go up to a cell site and you don't know what's there because everything looks exactly the same. And you can spin up and spin down different nodes at any time as you wish for security reasons.
The reason I say this, the aesthetics is totally different in the community of Hollywood than it would be someplace going out in a small town situation where they welcome you because there's more bandwidth because they're doing a big project or something.
Yeah, absolutely. It's one of the things that we hear most in the marketplace is the acquisition of real estate right now, is getting the real estate and then holding that real estate while you do the development, and how long it takes to get through something in Marin County or somewhere like that in San Francisco. When AT&T launched the iPhone, it took years for them to get new sites when they were getting crushed in the media because of the performance of the network. It was because they couldn't get any more sites and the amount of traffic that new type of device brought. So that is that is our advantage of having that real estate already, having our own construction and permitting teams that can go in and do that it's already a purpose-built facility for telecommunications.
And they do this worldwide as well too. That's something else too.
We do. Yes, we do it. 25 different countries.
So what percentage of your sites now have this facility available?
So right now we're in the infancy stage. We're at about 6. locations, but that's really only based on we're watching use cases develop. We're watching how they develop and where should the capital go for deployment. American Tower, one of the great things about us is we're an S&P 500 company. We do $8 billion in revenue every year. We have the capital ready to deploy. So if you have a customer that's ready to do something, if they want to commit to 3-4 racks, I mean, we could have something built within 6 months because we already own the land.
So is the plan to like get it at most of the sites, a small percentage of the sites? How close together do they need to be, do you think?
That's a great question. And again, it's because you can't predict what 5G is going to drive. Like we couldn't predict Uber, we couldn't predict Uber Eats, we couldn't predict all of these different types of things that came with 4G. We just knew 4G was coming and it was faster. I think though, are there gonna be 40,000 edge nodes? No. Are there gonna be thousands? Possibly. Could there be, as if we go back, whoop, I closed it out.
Well, you need that 5G bandwidth to do autonomous driving, right? So down the road.
Well, yeah, I mean,
How much of the like interstate do you have covered? And
yeah, all interstates are covered pretty much now with cell phone with cell phone coverage. But with mid-band spectrum, 5G spectrum that's coming out, not to get too technical, but the 5G spectrum does not travel as far, right? So the 800 megahertz frequencies that most people are on, depending on what state you're in, what carrier has what licenses, travels the furthest, but it carries the least amount of bandwidth. Now, you get to, there is gonna be some densification, but you could drive down the road and cars are gonna communicate with each other for a while, and then they're gonna need some type of uplink and downlink connection. I don't know if they'll, and I'm not an expert on self-driving cars, but I don't know if they'll need a permanent connection to a cellular network to drive. I think they'll do some of their own compute inside the car itself. They'll do some communication between the other cars around it to make sure it's safe, and then it'll dump data when it gets a connection, when it needs it. So we really believe that the high-speed connectivity coupled with the processing is critical for the advancement of not just self-driving cars, but let's just talk about its artificial intelligence, right? A self-driving car is artificial intelligence, right? Machine learning, that's a self-driving car. It's learning as it drives, and augmented reality and virtual reality. All of those things need edge data processing with high connectivity, which brings in the ultimate goal of having connections into the MNOs, and having compute and the real estate and the amount of sites that we need. We don't know exactly everything yet, but those are the three things we know. We know we need the real estate and the place to put it. We know we need the compute there to do it, and we know we need the connectivity to do it. And those advancements are gonna revolutionize every industry, right? So everybody goes, okay, that's great. Which one's first? We don't know. We don't know yet. Those are the things that we're looking at and looking for customers that are first movers that do want to test things like Ian talked about. Who are the R&D workloads? Who are the people that want to test these things, right? And there is going to be just endless type of advancements and things that we never thought about, just like we didn't think about just from 4G, and the things that we enjoy now that are just commonplace to us. And so that's what I mean. Our platforms will open up these new business cases, but we rely on the channel and people that are out there to bring those people in and get the message out at this point to help drive that ecosystem, because we're all gonna benefit, right? We're all gonna benefit by having this marketplace opened up. We don't have that crystal ball yet. We appreciate partners and the end customer that comes in is willing to take a risk. So what does it look like? This is exactly the point. I mean, if you've ever been to a cell tower, if you haven't, this is what a Verizon shelter looks like. This is what an AT&T shelter looks like. This is what an old Nextel shelter looks like. It looks like this, fiber bond shelter, right? Except inside of it now is the edge data center. It can go down to a quarter cabinet, half rack, full rack. It has DCIM, security cameras. As we talked about, it has hot aisle, cold aisle containment, secured access. We do dark fiber, right now. We do wavelengths and just pure internet connectivity. There is the 96 kilowatts of total power, 50 kilowatts of IT power, with a 100 kilowatt backup, dedicated backup generator right there, ready to go. So we have all these things that make it almost the same experience when you walk in, and we get that response when we take people and give tours that, wow, this looks like a data center, just a lot smaller. So again, the service offering and really how we can support customers' needs is, again, it's a turnkey distributed solution that we can provide. It's strategically located right now, that's the main thing, is how do we get to those tier 2 and tier 3 locations. So American Tower is generally in a majority of our towers are in suburban and rural markets. So we're not looking to compete against in tier 1 cities for these things. We're looking to open up new markets. We're looking to open up the Midwest, some of these places where people have to get on a plane to get to their equipment to do service on. And we'll be able to do those types of deployments, those farming deployments. We'll be able to do those water, those oil and gas, those types of deployments, because on the backs of the deployments of the M&O networks have been deployed already. Yep. So we agree with that too. We agree with that too. That most of the people that we talk to today are looking for dual redundancy. But we're also looking at 5G technologies and other technologies that would have to have a re-education of the data center marketplace to say, should the edge site be built for redundancy, or should the edge site be built to fail because you're gonna have multiple locations within a regional area anyway? So let's say there is a software program that, based on certain outcomes, is already through an orchestration. If something fails, it could shift your workload from West Phoenix to East Phoenix because you had 2 sites. So do you want to spend the money and what the price would be to harden an individual site, or would you rather have 2 physical locations? So I think that there is a discussion there. I would say that traditionally the data center companies are going to say, hey, we want this to look exactly the same and act exactly the same as we do today. We'll see where that goes. We only pulled in 1 for some of our initial POCs. There is, but does the failover give you other things besides maybe just a power failure? If that's what you're worried about, maybe you start taking some type of security risk, and you can just shut down. You can use the actual physical node location as a security device. You shut it down and move your workload over till you figure what's going on with your stack in that site.
I'm pretty familiar with spectrum and the various ranges of spectrum, from 100 to wherever. You get that 100, you get 2 many towers together, just like a door opener.
Yep.
You get close to that versus the 800, which is a long distance there. Are you focusing in any other of those that are there? Because years ago, the Defense Department owned only the 700 range, and now there's some new ones coming out. What are you looking at as far as those are concerned, maybe not just the 800 range?
Yep. So I was at Nextel in Los Angeles when we went through the rebanding process and went to 900 megahertz. There is a new CBRS spectrum band that is owned by the Department of Defense that is used for military radar and to land planes on aircraft carriers, but you're not going to land an aircraft carrier in the middle of Iowa or land a plane on an aircraft carrier there. So there is spectrum that's out there that we've looked at to evaluate the operation of private LTE networks, which we are, as a company, we're not doing that, but we've evaluated it. But you're going to see people, possibly manufacturers, maybe developers of maybe like a Disney or a company like that owns a corporate campus that might be out in the middle of the desert, that AT&T or Verizon is not going to come out and build their 5G network, where you could build a private 5G network that can then connect into a larger network. We are not operating radio access networks. We feel that that's competition. Yeah.
What's your uptime on SLA?
Sure. Our uptime is the same as 99.99. I think it's 3 nines at this point right now. but it has an automatic failover into from our power source has an automatic failover 10 seconds to get the generator up and running. And then it has a huge belly tank of fuel, and we already have contracts because we're already operating another generator inside that facility. So we already have the contracts in place for nationwide contracts for fuel and maintenance and all those types of things to keep it up and running. Now, if you have an event like we did in Texas, I think it was last year, that was like a force majeure event where even the diesel fuel froze on some of these things. So it was a difficult event, and we learned a lot from that. But yes, it's the same type of uptime and availability, and we're going to continue to improve that as we get use cases. But again, the decision it comes to how do you perceive the edge and what is it supposed to be? I mean, no doubt that these types of facilities are going to be truly your hardened facilities, but do these ones really need to be truly hardened, right? Do you want to pay for that? That's what the end customer would have to do, right? And if you have 11 racks in there, can you make a business case to pay for it, right? So can you charge what a customer is willing to pay to make it as hardened as a core facility? Those are questions that we love. That we.
Also gets down to what is the cost of it?
That's exactly correct. Exactly correct. Can those and what workload is happening there, right? Yes.
So do you help companies figure out what the baseline is in regards to what application or workload based on the latency would determine that, this would be better to move to an edge type of data center as opposed to a regular data center? I mean, how do you determine?
Do you want to take that?
Yeah, so what's going on right now is this company is trying to secure information, and so if there's a latency-prone workload that really needs to be, like maybe rural America, so think of like in Yuma where you have a lot of agricultural plants, and you have more and more packaging plants trying to become digitized.
Right.
Data center services there are not non-existent. I mean, it's very hard to get data center services out there. So it's perfect for that kind of workload. So that's one thing that you gotta start tuning down now. Like something that is actually moving to the edge, to the true edge, are like function as a service. So parts of code are actually starting to get moved as functions into the compute stacks out there, and that's just to distribute the workload.
Okay.
So that's just with that additional processing power and low latency.
Okay.
There's still a lot of R&D, like what we're seeing is a lot of R&D workload right now really moving there. That's really the focus.
I think you hit it right on the head, which was we don't really know where everything's taking. I mean, you can take this
we don't know where the end state's going to be.
Yes.
Well, we do know where the starting points are.
Yep.
We do have starting points right now.
Yeah.
The end state's going to evolve, and it's going to evolve rapidly, right? And it's going to mature technology. The human mind is very creative. Nobody could have forecasted what the internet would look like today. So imagine, fast forward 10 years from now when you have thousands of these sites deployed, you have 5G connectivity very mature at that point, permeating everything. We're getting basically all of our cell phones are getting, a couple of gigs, 3 gigs of active content, from a transport perspective, right? Everywhere. There's going to be need for more compute and more processing and more storage.
No, it's not going to slow down.
It's not going to slow down.
Yeah, and like Ian said, what we do know now immediately is that using the Yuma example is that location matters.
Yes.
Location matters not only for low latency applications, but for regular data center services that people can't get in smaller markets that are going to need it, right? Everyone's going to get 5G at some point, and everyone's going to, like everybody has an application like Uber. Having those services in your community are going to become just as important as we hear every day about the need to provide wireless connectivity in rural markets. And we haven't completed that yet. There's been a drive for that for a very long time. It's going to be the same thing for these types of IT services. So regional diversity matters, and that relates back to latency as well.
Cool. Well, thank you for your time. Appreciate it.
Thank you.
Thank you.